Welcome to conceptual classes on organic chemistry. Today's class is class number 9 and I have chosen the topic alcohols and phenols, and this is the first part. Today's scheme of this topic is introduction, classification, hybridization, splitting of contents of the chapters, subdivided into reagents applied in the chapter, important compounds, extra information, name reaction involving the chapter, preparation, and at last chemical reaction. So first of all, I am touching upon introduction. What are alcohols? Alcohols are nothing but hydrocarbons when one or more hydrogen is replaced by hydroxyl group. For instance, this is alcohol. Simply, when one or more hydrogen is replaced by hydroxyl group, it gives alcohol. Next, very simple introduction. Next one is classification. Classification based on OH group. Number 1, monohydric. Number 2, dihydric. Number 3, trihydric. Alcohol means if there is one OH group, then it is monohydric. If there are two OH group, it is dihydric. If there are three OH group, then it is dihydric. Very simple. Depending upon the number of OH groups, the hydrogens are named as monohydric, dihydric, trihydric, etc. Now, number 1, monohydric. Monohydric alcohol again are of different type. Number 1 degree or primary. Very simple. If OH group is attached to that carbon which has already two hydrogen, OH group attached to carbon, the chain will extend. Where there is two hydrogen, then it is 1 degree alcohol or 2 degree alcohol. Number 2, 1 degree alcohol. Number 2, if OH group is attached to carbon which has only one hydrogen, is called dihydric. One hydrogen, two hydrogen, monohydric. One hydrogen, if OH attached to the carbon which has two hydrogen, it is 1 degree alcohol. If OH is attached to the carbon which has only one hydrogen, it is called 2 degree alcohol. And if OH attached to the carbon which has no hydrogen at all, it is called 3 degree. Very simple. 1 degree, 2 degree, 3 degree. Monohydric alcohol, first 3 type, 1 degree, 2 degree, 3 degree. Second type is allylic alcohol. Again, allylic alcohol maybe 1 degree, 2 degree, 3 degree. So before allylic, I am just stretching upon minutely follow. This is allyl group. Allyl group. If there is OH, allyl alcohol. If there is X, allyl halide, allyl chloride, allyl bromide. So here we will use OH or Cl to get allyl alcohol, and that group is called vinyl, very famous. And if you now add OH, halogen, fluorine, chlorine, so the vinyl chloride, vinyl alcohol, like this. So depending upon this group, allyl, very famous group, allyl, classified allylic group as 1 degree, 2 degree, 3 degree. Let's see. CH2 double bond, CH2 OH. It is 1 degree. Now CH2 OH 2 degree, CH2 CH. Example is, this is vinyl alcohol, because here there is one carbon, here there is one carbon, these two carbon has double bond, CH double bond CHOH, CH, there is H2, double bond CHOH, so it is vinylic alcohol. Number next one is benzylic, BENZYLIC. Benzylic alcohol is very simple. This is CH2OH. It is 1 degree. If one hydrogen is less and it is replaced by any other group, it is 2 degree. If another hydrogen is left and replaced by another groups, it is 3 degree. If CH2OH 1 degree, if CHOH 2 degree, if COH 3 degree. So we have seen alcohol, type of alcohol, 1 degree. First one was monohydric, dihydric, trihydric. Monohydric alcohol was again divided into allylic, vinylic, benzylic alcohols. So this is all about the classification of alcohol. Next one is hybridization. So hybridization, in very simple way we can show you hybridization like, so this is sp3 and this is sp3 again. How? That day in my class number 8 I have mentioned, I have shown you the small trick. This is one hand, this is one hand, two hand, 3 and 4 hand. 4 hand is 3 and 1 4. It is sp3 hybridization. Very simple way. This is hybridization. But there is a bit difference bond angle from tetrahedral bond angle, which tetrahedral bond angle was 109.28 minutes, but it is this. This is due to the presence of lone pair and repulsion of a bulky group of this. You will get it valence electron pair repulsion theory in bonding chapter. This is the bonding and hybridizations in alcohol. Now, basing upon this, we will just mention some facts about physical property. Physical property, that is physically how alcohol looks like. Number one, if carbon-carbon compound number is about 12, these are liquids. these are liquids, waterless, and burning test. Burning test. And if number is more than carbon number is more than 12, then these are solid, odorless, like this. This is very simple information. Now, from if you go to the hybridization, you see there are two lone pairs and one hydrogen bond, and due to this things, one got oxygen and this is hydrogen, and there is carbon. So out of this, oxygen is more electronegative than carbon and hydrogen. So there is dipole moment. Oxygen is a bit negative, another part is a bit positive, delta positive and delta negative. Due to this process, it produces dipoles. So there is dipole in alcohol. Number 3, due to the presence of this hydrogen, due to the presence of this hydrogen, due to presence of this hydrogen, due to presence of this hydrogen, we see it has got hydrogen bonding, and alcohol can make hydrogen bonding with water, alcohol itself can make hydrogen bonding with same things. There is intermolecular hydrogen bonding, there is association, is a semblance of association, that's why boiling point of alcohol is a bit more than others. Number 3, in terms of physical property in alcohol, there is two parts. One part is carbon, and that carbon change will extend. It may extend a lot, carbon, 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 and there is OH and H. Due to the presence of this part, alkyl part, this alkyl parts, it makes the compound less soluble in water, and due to presence of this, it makes soluble in water due to intermolecular hydrogen bonding. So there is a fight, tug of war between these two. One part makes decrease solubility, other part increase solubility. So when the carbon is of about number is of about 4, these carbons are soluble in water because intermolecular hydrogen bonding overpowered the alkyl parts immiscibility with water. That's why they are soluble. But as soon as the chain of the carbon goes on increasing, so hydrogen bonding, power of hydrogen bonding decreases and insolubility appears. So we see in terms of solubility, as the alkyl parts increases, solubility decreases, and other is solubility is inversely proportional to branching. This explains a lot of things. If it is 1 degree, if it is 2 degree, if it is 3 degree, we see branching increases. CH3 appears. When CH3 appears, then branching appears 1 degree, 2 degree, 3 degree. So more the degree is CH3 groups, alkyl groups are there, the surface area will be reduced. So melting and boiling point will decrease. So 1 degree will be more soluble than 2 degree, will be more soluble than 3 degree. As more the branching, less is the solubility. So this is all about the physical property. Now I have splitted the chapter, contents of the chapter into different parts. One is reagents, very important. Without the splitting, you can't go for the reaction and preparation of these things. You should have sound knowledge on the reagents, otherwise you forget about studying chemistry. So in each and every chapter, first of all, I discuss some of the facts regarding so number of the reagent, type of the reagents are, I myself has organized into different categories. First one is oxidizing agents. Let's see what are the oxidizing agents actually used in the chapter of alcohol and phenol. So these oxidizing agents are very simple and common. One is K2Cr2O7, H positive, Na2 Cr2O7, H positive. This is oxidizing agent. These are oxidizing agent. Number 2 is PCC, pyridinium, chlorochromate. Number 3 PDC, pyridinium, dichloro, chromate. Number 4 H2O 4. Number 5 Jones reagent, chromic anhydride, sulfuric acid, water, all in acetone. So these are the very common and simple oxidizing agents are being used in the alcohols. So first of all, we have learned about the oxidizing agent, what oxidizing agents has what functions. So out of this, we will focus with these two tremendously important, because these are the oxidizing agents, strong oxidizing agent, and pyridinium, chlorochromate, C6H5 NaCl CrO3. This is the formula. Sometimes in entrance exam questions are being asked what is the chemical formula of the pyridinium, chlorochromate. This is the formula, and Jones reagent is this. Now, what is the speciality of this? So, speciality of this is it converts 1 degree. You please keep it in your mind. 1 degree alcohol means OH. 1 degree alcohol into CHO, and 2 degree alcohol into ketonic group. This is the function of this. And another speciality of this PCC is that if there is any double bond in the structure, this double bond is not affected by PCC. This double bond is not affected by PCC. Am I right? So PDC, it has same function, 1 degree to CHO, 2 degree to CH. H34, it is actually 1 degree alcohol is directly converted to carboxylic acid. And Jones reagent, especially in many offense, a 2 degree, here 2 degree alcohol is converted to ketone, and if 1 degree is there, so 1 degree transforms into CHO, and then CHO further on oxidation gives COH. So this is Jones reagents. So these are the, in short, some oxidizing agent mentioned in the chapter alcohols and phenol. Let us think of explain some of the reducing agents. Mind that oxidizing, reducing, these are the main backbone of this chemistry, organic chemistry chapter alcohol. If you know their function and what are these, so then you can proceed with any type of reaction. Otherwise, by practicing simply you can't do anything. So what is reducing reagent? So reducing reagent, amongst reducing reagent, will first of all write sodium, lithium, aluminum hydride, sodium borohydride, BH3, THF, and the nickel hydrogen. These are the special type of reducing agent. I will now talk about this one. This is very, very important. And what about this? These two, lithium, aluminum hydride, and borane in tetrahydrofuran. These any each one of them can reduce, in short I am telling you, try to keep it in your mind, can reduce ester group, can reduce ester group, can reduce HCHO group, can reduce COOH group, can reduce these groups. Now this is of about this. Now come to NABH4. This is selective reducing agent. Mind about this one. This is selective reducing agent, cannot reduce the above functional groups, but can reduce CHO only to CH2OH. So I have already mentioned in my previous class number 6, I think, that reduction means addition of hydrogen. Reduction means, very shortly I am showing you how reduction occurs. You see, reduction means addition of oxygen. So hydrogen, sorry, one hydrogen will add up here and other hydrogen will add up here, and that bond will vanish. So you are getting CH2OH. CH2OH. Mind that reduction is addition of hydrogen. In sometimes lithium there will be 4 hydrogen, in sometimes nitrogen there will be 6 hydrogen. It is later on you will find it. So it is very selective. That is, this sodium borohydride has the ability to reduce CHO group to CH2H groups, and it can't reduce ester group, aldehyde group, CO group, epoxy group. Am I right? Now, just I am taking a very small example. Just to see. Of this one. So mind that, just now I have told that a sodium borohydride is a very selective one, which has the ability to reduce CH2 to CH2. Whatever the structure may complicate the structure may be. This is ester group, this is carboxylic group, this is aldehyde group, and epoxide group. So out of this, it has the ability to, these groups will remain untouched. It has no ability to reduce. So your answer will be, all the structure will be remain same, but here only this part will be, here will be like this, CH2OH. CH2OH. This line indicates CH2OH. So here will be this one. I am not, for time, considering the time, I am not showing the structure. All structure will remain the same. Only in this place, this will be from C. Out of this structure, you write this one. This is the implication of sodium borohydride. Now I am talking about, I am trying to explain other reducing agents. Number 1, number oxidation reduction. Number 3 type, Type 3 is dehydrating. Dehydrating means loss of water reagent. Just you keep it in your mind. Concentrated sulfuric acid. H3 PO4 anhydride. Zinc chloride, and lots of things are there, but we will just discuss in the chapter. These are the compounds. If you find to react with any other things, then instantly we will remove water from this one. So these are this reagent with the help of which water is released from the reactant. So that's why these are called dehydrating. Number 4 type is dehydrogenating or dehydrogenation, means loss of hydrogen, and especially in this chapter we will talk about this one. If we find this one, and mind that loss of hydrogen, if addition of hydrogen is reduction, then loss of hydrogen will be oxidation. It is nothing but oxidation. We will find a lot of reactions of alcohol with copper at 570 degree Kelvin. Just I am giving you some idea about the reagent. Next one is extra information. Important compound. So before important compound, I am telling you some extra information. What are extra information? Extra information is very simple. If you get cyanide group, if you hydrolyze, that cyanide group becomes C double H group, and if alkene group is there, and if you hydrolyze means water is like this. Okay, one part goes here, other part, any part anywhere. So it will be just like this. And if you reduce means addition of hydrogen, am I right? 2 hydrogen will add up. So one part hydrogen here, other part hydrogen here, CHOH. So these are some extra information. We will find it while we will do some conversion. So beforehand I am explaining that will come in the solution of the many type of reactions in the chapter. That's why in extra form I have shown you this one. Next I am coming to type of important compounds. So what are important compounds? First of all, we will talk about this. Everybody of you know this is methanol. Am I right? It's another name in entrance exam and general exam. Very often in board exam and CRT entrance it often comes. Another name is wood naphtha, and another name is carbonyl. Very often asked. Next one is, you may forget, it will come in it, water gas. This is natural gas. This is 80% alcohol plus 20% absolute alcohol gives you power alcohol. Yes, natural gas, petrol, sorry. And next, next one methanol is mixed with ethyl alcohol. To make ethyl alcohol unfit for drinking, and that is called methylated spirit, SPIRIT. And ethyl alcohol is also make unfit for consumption by adding copper sulfate and sometimes pyridine. Am I right? And next I am coming to some of aromatic compound. This is phenol. So you see, this is phenol. Its derivatives are often used as antiseptic. One example of antiseptic is 1,4-dichloro-2,5-dimethyl phenol. And when you see the name, you will find it a bit huge name, but when I tell you the name, you will understand. This is Dettol. Each and every one uses this at home. So 1,4-dichloro-2,5-dimethyl phenol is literally derivative of phenol. So phenol is an antiseptic. Now another important thing, you will get it during the solution of the chapters. When we will come to the reactions of the chapters, this is oil of wintergreen. It is aspirin, Celon, very often used in sunshine protection under sunlight as lotion. Celon. These are the very important compound asked in entrance exam. The oil of wintergreen, and aspirin and Celon. We will get the structures and name once again in the chapter, but beforehand I am make you familiar with this chapter, with these compounds. These are very important compounds. And next of important type of compound is again from phenol. You see, this is common name is catechol, and if OH this is resource phenol, and if OH is here, hydro. Very important, very often asked question. We will discuss in the chapter itself. Just you try to keep the names in your mind first, and that is orthocresol, if this is here, metacresol, if CH3 group is here, paracresol. So we have got some of the important compounds in the phenols and alcohol chapters. So after this we have done. So next we have left out one of the part is name reactions. What are the name reactions are being discussed in the chapter? First of all, very common name reactions are, we will discuss in detail, name reaction used or you will find in the chapter is Cook's reaction. Cook's reaction. Number 2 is Diamond reaction. Number 3 is Gattermann reaction. Number 4 is Racing reaction. Number 5 is Number 6 is Scott and Bowman reaction, and Bowman-Blah reaction. Cook reactions, Diamond reactions, Gattermann reaction, Racing reactions, Buchera, Buchera, Scott and Bowman reactions, Vogel, Dault, Vogel-Blah reaction, and one by one in the chapter we will. Well, this year in NEET 2023, a question asked. The question was like this. Benzene was given and there was a group, and that group was that group. And a bit earlier I told you that that group is nothing but allylic group. And when this group is attached to this benzene is allylic benzene. And you are asked in the option, it is benzylic allylic benzene, benzylic benzene, lots of other options are there. Answer was allylic benzene. So those who know the allylic group, they can answer the correct answer. So far as I know, some of the student has given wrong answer due to the poor knowledge on the allylic group. So one point I am here showing you that you write the alkene, you write propene, am I right? And you remove one hydrogen from here and make it a group. So from propene, the group which appears is called allyl. This is allyl, this is allyl. Where to keep the trick in your mind? And another was, this is ethene. You remove one hydrogen from this and make it a group. This group is called vinyl. So in your life you will not forget what is allyl. You write propene. So from propene you remove one hydrogen, that is allyl. And you write ethene, and from this you remove one hydrogen, that is vinyl. So this is allyl and vinyl. Question comes here. Very simple question was there. It is from concept again. So this is the question from this one. So now I am going to start. I am going to start preparation now. This part is very simple and you minutely follow. Preparation of alcohol. One is from alkene, and from alkene it is divided into two parts. One is hydration of alkene, and second one is hydroboration oxidation. Very simple, this is not tough. And second one is reduction of aldehyde, ketone, carboxylic, and third one is the last one is from Grignard reagent. Just to see the beauty of chemistry, I am showing you. You follow me from alkene. You take one alkene. A bit earlier I told you that in extra point, if you recall, you go back to my chapter, I wrote in this way, hydrolysis, and I told you hydrolysis means water when breaks into two parts of OH. Any part you add here and any part there, H and OH. This is hydration. A bit earlier I told you. Now let's see what happens. Let's see what happens. I am taking one alkene. This is acid hydrolysis. Means acid and water. Because without essence of acid, water doesn't back, not normally back as H plus and OH negative. So it is called acid hydrolysis. As per rule, what I told you here is water has broken into two parts, H plus and OH plus. Any part, two parts, wherever you want to add, you add. No matter, you add in this way. Okay. So for those who are in NCERT or in state exam, board exam, if you want to appear, sometimes mechanism of this is asked. I am showing you the mechanism in very short way. Please follow the mechanism. First one is protonation. Wherever there is acid, there is H plus, and there is water. Am I not? First of all, what's happened? Water is lone pair of electron, and this is H plus. Always H plus get attached to this one. Very simple thing. So what you get here is hydronium ion. Many of you know the fact. Now this hydronium ion, this is your alkene, am I right? And this is hydronium ion already produced. This step is protonation step. So what's happened here? This attached here means what? This line arrow means H is attached. You attach H. When you attach H, there is lack of bonding, valency of this. You are getting this part. Now, second part is attack of nucleophile. Nucleophilic addition is here. So nucleophile, in another class, nucleophilicity in the previous class, probably in class number 8, I told you, base as I said, nucleophile, and base sometimes acts as acids. Sorry, nucleophiles. Sometimes base is abstract hydrogen, and sometimes base attack. When base attacks is called nucleophilic attack, and this is attached to this carbocation. So here nucleophile is attacking means this will attach to this one. So what happened here is this is attaching like this, getting attached in this way. and this part remain as it is. This part remain as it is. Next part is very simple. Third part, deprotonation. One proton will be released in presence of water. Water here is a base. Base will abstract one. It will not attach. This base, water molecule abstract this. So what's happened here is COH is plus. Am I right? C double bond H. Is base, not nucleophile. And this is withdrawn here negatives. Charge vanishes. Your answer is COH CH. This. You are getting alcohol. This is mechanism, 3-step mechanism. Very simple. Very simple. You just practice one time, you will get the result. Now, first part is hydration of alkane. I have already done. Second part is hydroboration oxidation. So you take hydroboration oxidation to take an ethene. Am I right? Borane BH3, diborane B2H6. So write borane as like this. You can write this. So minorly follow this step. Many students make mistakes here and they can't continue this one. Wherever alkene is there and borane is there, this hydrogen get attached to this one. So what you get here is CH3, CH2, single bond CH2, and that part will attach here. This is first step, and if you mistake in the first step, you can't continue the reaction. Now you see, again we are taking ethene, CH double bond CH2. So when ethene is there, the answer is this. When ethene is there, answer is this. Earlier we have shown when ethene is there, answer is this. When we have added another ethene, then again you will get this part. This ethene will give this part, and again when ethene is there, BH2 replacing one hydrogen, ethene enters as CH3, CH2, CH2. So CH2 part attached with BH2. Now your BH2 will become BH, and another same CH3, CH2, CH2 will come. So you are getting CH3, CH2, CH2 twice, replacing one hydrogen. Replacing one hydrogen from here. Am I right? Likewise, again you add CH3, CH double bond CH2. Again you replace that hydrogen, and in place you add this unit. CH3, CH2, CH2, it will become thrice. Now, what is the final step? The final step is hydrogen peroxide and alkali OH. That's become CH3, CH2, CH2, OH. One very striking information and fact is that it is nothing but anti-Markovnikov. Anti-Markovnikovs. So what Markovnikov told, here nothing but final assumption is that water is broken into this part. So which part will enter in which part, this is the final fact. So according to Markovnikov, the negative part will attack to that carbon on both sides of double bond which has less number of hydrogen. Negative part get attached. I am summing up the reaction. Negative part get attached to that carbon on both sides of double bond which has less number of hydrogen. So as per Markovnikov rule, OH part should attach with CH. But our answer is that OH part has attached to this one and H part has attached to this one. It is anti-Markovnikov rule, and this is only because of the fact that of peroxide there was a crash effect. Anti-Markovnikov rule was there, crash effect, peroxide effect. In first year you have got this one. So whenever you got like this, you do reverse of anti-Markovnikov. In exam, how you are confused, I am telling how you are confused. You are given the question like this: CH3, CH, double bond CH2, BH3, H2, O2, OH. Everything is given above and below the arrow, and you are asked to write the question. So you can recall that it is borane, it is hydrogen peroxide oxide, and it is nothing but anti-Markovnikov. What are OH and H? OH and OH will be anti-Markovnikov. You remove this double bond, one bond, and add up OH in this part and H in this part. This is the answer. Answer is CH3. Without doing any mechanism, you write the answer like this. This is the shortcut to keep the things in your mind. Now, this is very important in entrance exam point of view, in state NCERT, in any type of exam, this is given. Am I right? So our next part is reduction. Now, reduction is reduction of CO group, CHO, and reduction of CO, reduction of C double H. Let's see what's happened. R, C double bond, O, H. You give palladium and add up hydrogen. Reduction is nothing but addition of hydrogen. So hydrogen, you keep it in your mind that whenever hydrogen is getting attached, there is some rules. If lithium is there, lithium, aluminum, you keep it in your mind. It is very important. There will be 4 hydrogen. 4 hydrogen will attach. If nitrogen is reduced, addition, you will add 4 hydrogen. 6 hydrogen. In other case, other case, you will add only 2 hydrogen. Okay. So if you add 2 hydrogen, your result is RCH2OH. In the simple form, you try to know the rule of chemistry. Otherwise, in each and every part, you have to write the answer blindly. So to write answer blindly is wrong. You can't. If you know the rules, simple rule, and you write the answer, you will find interest in chemistry, and whatever question answer appears in exam, you can answer yourself. So you see, very simple rule, as per rule. So how we add hydrogen? Means addition of hydrogen, am I right? Or either 2 hydrogens or 4 hydrogen or 6 hydrogen. Am I right? We will add 2 hydrogen. 1 hydrogen will add to oxygen, and other hydrogen will add to carbon. And this is earlier this same. So what you get is RCH2OH. RCH2OH. This is reduction. You keep it in your mind, otherwise you can't. How it CH2OH comes, you can't explain yourself. You will not get satisfaction by learning this. So now what's happened here is, if you use ketone, RS, you use sodium borohydride. So again you are adding, I will write the answer as this, but you will not be happy how the answer appears. The answer is very simple. Once again, answer is very simple. We can justify the answer by shortcut. Say RC double bond O R dash. Am I right? You are adding one hydrogen here and other hydrogen here. So are you not getting RCHOH R dash, 2 degree alcohol? Am I right? So now third one is carboxylic acid. Reduction of carboxylic acid. With rule you reduce, then you will find easy. So we should use a very expensive um, reducing as a lithium aluminum hydride, and second step water. So means in one time you can't use this two. In first time you use this one, second time you use this one. After completion of this you can do this one. So I am not showing you the mechanism. What will be the answer? Answer will be the RCH2OH. Simple clue. What is the clue? Clue of the reaction that CH2 has become reduced as CO has reduced as CH2. Now what is the justification? Not mechanism. What is the justification? We can show. The justification is here it is lithium will add up 4 hydrogen. Reduction means addition of hydrogen. Over here we are adding 4 hydrogen. We have to add 4 hydrogen. So one hydrogen will add up here, other hydrogen will add up here, and this one will be like this. So from this, it is not mechanism. I am showing the shortcut. I am the shortcut. You just do one thing. You remove water molecule. Am I right? So to remove water molecule, are you not getting aldehyde RCOH? Am I right? Minutely follow. You are adding mathematics. How much hydrogen you have added? How many hydrogen you have added? You have added 2 hydrogen. In our hand, they are left 2 hydrogen more. We have to add, and if you add 2 hydrogen more, 1 hydrogen is here, and other hydrogen is here. So RCH2OH. Our answer is justified. Am I right? So we have got third type of reduction of carboxylic acid. Now there is a very important question, and tricky question asked in the exam, that which one of the reduction process is used in commercial process. The previous last year, before the last year, a question was asked, preparation of phenol in NEET exam. What was the commercial process of preparation of phenol? Very simple question, in your textbook it is written, but maximum of you couldn't answer this question. So you see RC double bond O OH. To do one thing, R dash OH, alcohol, add up alcohol. So what you will get here is you reverse it, OHR. So from this OH and H, I am not getting water. So water will remove out, release out, and what you get is ester. Am I right? So on dehydrogenation, hydrogenation of this ester will give you RCH2OH plus R dash OH. It is a commercial process. Whatever the answer in the last step I have written, you will not be happy with this one. It is commercial, COMMERCL, commercial process. Ester is prepared and hydrogenation occurs. Hydrogenation means generation means hydro means hydrogen, generation means addition of hydrogen. See this step, what's happened here is CO is here. Am I right? And other, it is shortcut, not mechanism. It is again, once again I am telling it is not mechanism. Other hydrogen is getting attached to here, not mechanism. So it is plus, and here bond, you remove the bond. You remove the bond, you get RCHO. Means RCHO, if you balance this one, this will be this, and this will be R dash OH. Am I right? And you do once again, you add up another hydrogen, one hydrogen here, other hydrogen here. So here, so you are getting RCOH HH. Is it not RCH2OH? Is it not RCH2OH? Yes, it is alcohol. So it is the way where alcohol is prepared commercially. Question asked from this point, on this point. Am I right? So our last point of preparation is Grignard reagent. From Grignard reagent, it is very important one that this is C double O group. In my 4th class or 3rd class, I have shown you the mechanism or the way, shortcut way how you will react Grignard RNGX. If you recall, I told you this is metal, you give it plus, and this is Ampalang mechanism. I told you the polarity inverses. In my class, you go to the back of my classes, you will find. So what happened here is, this is nucleophilic attack, nucleophile addition. Nucleophile attacks here. Attack means nucleophile attach. Extract means remove hydrogen, take out one hydrogen, and we get here is C attach, and one bond withdrawn here is gets negative, and this is positive. Am I right? Negative part get attached with positive part, and with negative part positive part attached. Am I right? And one hydrolysis, I told you, one hydrolysis means H plus and O is negative. Am I right? This bond breaks into this. This is negative, so positive part proton and this apart. So you are getting one part alcohol, other part is something else. This is the shortcut of this. Now let us check how can we. This is very important from state board, NCERT, board and state exam, and also in entrance it is very important. So let us take one example of CH3 C double bond O COH aldehyde. With aldehyde, let us name the Grignard reagent, methyl magnesium bromide. Let's see how we get the product. So follow my shortcut rule. This is minus Ampalang mechanism, reversibility of theory, reversibility of polarity, this. Am I right? And this is what partially negative, and this is partially positive. Am I right? So negative part is attached here. So you see the beauty of chemistry. You know the rule and write the answer. So one thing you do for your convenience, you make aldehyde C double bond O here and H here. So here you are getting negative part, here you are getting positive part polarization. Okay. So what second here is CH3, here is H, and that part will come here, that is CH3, and O is here what? Negative. Am I right? Negative will get attached with the positive. So O MgBr. Am I right? So last part is very important and very simple. Hydrolysis means O is negative and is positive will attach, and the rule is that it is negative, it is positive, so positive part will come here and negative part will go there. So what we get here is CH3 CH CH3 OH. This is secondary alcohol. This is secondary alcohol. Now you do one thing. You make the reaction with this is acetaldehyde. Am I right? You make the reaction with formaldehyde. Make it H. Am I right? If you make it H, you are getting here H. So you are getting here H. So you are getting CH3 CH2OH. You are getting 1 degree. So we have got 1 degree and 2 degree. Now what's happened here? You write better. You write a ketone. You write a ketone. Am I right? So you make it in this way for our convenience, ketone, and take the Grignard reagent as this. So let's see what happens as per our shortcut, not mechanism. This is minus and this is plus, bond is withdrawn here, and that minus part will get attached with the plus part. So you do this thing, CCH3, or this is negative and this is positive, positive will get attached with this one. Am I right? So you are getting here CH3, and along with the negative part Mg will attach. Am I right? And last part is hydrolysis, means H and OH negative. Again this will break here, you will get H, and here H part, sorry, H plus and OH minus. So what you get is CH3, CH3, CH3 OH. You are getting 3 degrees. So it is an excellent synthesis and excellent process where you get 1 degree, 2 degree, 3 degree alcohol from Grignard reagent. So the condition is that if you treat the Grignard reagent with formaldehyde with Grignard reagent, you are getting 1 degree alcohol, and if you use it acetaldehyde with Grignard reagent, you are getting 2 degree alcohol, and if you use acetone with Grignard reagent, you will get 3 degree alcohol. This is the preparation of alcohol part as per your syllabus. Bit by bit I will proceed with another type of preparation, important type of preparation of the. Now preparation of phenol. Phenol this is phenol, and its another name is carbolic acid, sometimes asked in entrance exam, any normal exam, carbolic acid. So one thing here I recall that a bit earlier I wrote the structure of cellol and oil of winter. So how will you keep it in your mind? I am showing with a small tree. First of all, you should know this compound. The name of this compound is salicylic acid. Am I right? And if one hydrogen is removed from carboxylic group, that group is called salicylate. O8, C double O group is O8, salicylate. Now from this part, if we add by any means, by reaction, CH3, here if you place CH3, this is called methyl salicylate, and this is oil of wintergreen. Sometimes what is the common name of oil of wintergreen is asked, you write methyl salicylate. So it is actually come from, it has actually come from salicylic acid. One hydrogen is removed, salicylate, and if CH3 group is there, methyl salicylate. And if in this place, if you enter phenyl group, that is called phenyl salicylate, phenyl salicylate, and that is called Phenols. It is common name, it is common name, it is another name. So this is how you should keep the name of the reagent in your mind. Am I right? Now we are trying to prepare carbolic acid, means phenol. We will first prepare it from chlorobenzene temperature is 623 Kelvin and pressure is this. Sodium phenoxide ion, then HCl, this is there we got that phenol. But here you one thing you keep it in your mind, you just try to understand that it is actually substitution reactions here, bond breaks here, and that's why benzene or aromatic compound doesn't easily show substitution reaction, but under drastic condition, temperature is high and pressure is high, we have done this. Am I right? Number 2, you take benzene, oleamer concentrated, H2SO4. This reaction is known to you all. From this you get benzene sulfonic acid, and from here if you treat it sodium hydroxide, you will get phenol. Third one is to take aniline, and in my previous class I told you nitrous acid, Na2 plus HCl. This will give a very important compound, benzene diazonium chloride. Am I right? And I have already given this reaction, benzene diazonium chloride, in BOM in entrance exam 2 years ago. A question was asked, what's happened on benzene diazonium chloride is treated with water in one condition? Answer is phenol. So fourth one is very important. This is isopropyl benzene. Isopropyl benzene. Am I right? So isopropyl. From this name, I have one thing came into my mind, that CH3 CH2 CH2OH. CH2OH. Am I right? CH3 CH OH CH2 CH2OH. Number 1, number 2, number 3 CH3 CH CH3 CH2 CH2OH. Number 4 CH3 CH3 CH3OH. 1 2 3 side 4 1 2 3 4 1 2 3 4. There are 4 carbons. So how will you name it? There is some confusion about these things, and very often sometimes students fall in confusion when iso word is there, and sometimes in the exam, entrance exam or state exam or board exam, NCERT exam, common name isopropyl, isobutyl alcohol, some word iso is used. So if you, these are common names, if you cannot write the structure, you can't give the IPC name. So which one of the following isopropyl alcohol, which one is secondary butyl alcohol, which is tertiary butyl alcohol, questions are given. So today I am giving you some concept regarding iso, word of iso, how it is working. So mind that this is N-butanol, simple, N-butanol. Now when functional group is attached with number 2 position, from this side 1 2 1 2 1 2, second position functional group is attached, then it is called sec-butyl alcohol. Minutely follow this thing, sec-butyl. And now again in these 2 position of carbon, not functional groups, some groups is there. Maybe alkyl, maybe phenyl. second 2 position, maybe phenyl, maybe alkyl, not functional group, then it is called iso. In place of functional group, if some groups, alkyl or aryl groups is attached, then it is called iso. That is called isobutyl alcohol, and it is tert butyl alcohol. Tert butyl alcohol. So the common name is named in this way: N-butyl 1, 2, 3, 4 butyl butanol 1, 2, 3, 4 butyl. What is there? 2 position. Functional group sec. Secondary butyl sec butyl alcohol 1, 2, 3, 4. As a whole, all the carbon is counted. Butyl, butyl, butyl 1, 2, 3, 4 butyl. So if functional group are attached to 2 position, it is secondary butyl. Is alkyl group or aryl group is attached iso, and then you count all the carbon. That will be your nomenclature. Here you see in 2 position phenyl group is there, so isopropyl benzene. Isopropyl benzene. Now this reaction is very important, and it's one of the important name in important compounds I have shown you. This is cumin. This is cumin. So what's happened when cumin is placed in air? When cumin is placed in air, say we can write it for our convenience. Cumin or isopropyl benzene. Cumin is kept in air. So what's happened here? So in the previous class I told you this is hydroperoxide, and if OO is the main chain, peroxide, hydroperoxide. So it is cumin hydroperoxide. Cumin hydroperoxide. Peroxide. Cumin hydroperoxide. That cumin hydroperoxide breaks in presence of acid to give you this part breaks, gives you CH3, COCH3 and OH and phenol. It is not mechanism, just simple way I am showing you. We have got phenol. Worldwide, this is the process where a huge amount of alcohol is prepared from cumin. This is very important from exam point of view. So now this is all about the preparation of phenol. Now I am taking some example, textual example of your chapter, how to solve this is CH3 a question is given in your chapter like this. I am showing you the shortcut, how you get the answer. Shortcut is there, this. You are getting this 2 things, and you just, it is unsymmetrical king. One carbon is having less number of hydrogen and one carbon is having more number of carbon. According to Markovnikov rule, just you add, you will get the result. CH3 CH OH CH3. That is, negative part will get attached with that carbon over both sides of double bond which has less number of hydrogen, that is OH, and positive part which attached to the carbon having more number of hydrogen. You will get this one. But if it is 1 mark question, this is okay, but if it is 2 mark question, you should give the mechanism like this. Am I right? So what's happened here is you are getting bond CH3 carbocation. Yeah, water is there again. Am I right? This will attack here, and you know attack of this means attach of this CH3 CH HH plus this CH3. Next step is deprotonation occurs. So you get CH3, CH, OH. This. If you can't understand the mechanism is very simple. You just follow this one. Am I right? Number two is if you minorly follow the splitting of the contents. I gave an example where NBH, for I over and over again tell, if you don't know, if you do not have the idea on the reagent given in the on the arrow, you can't proceed anything. It is a reducing agent and it is mild reducing agent. And I had given an example that it cannot reduce carboxylic group, it cannot reduce ester group, it cannot reduce this group. I showed you with an example. So due to this mild reducing action, you cannot touch here. It is ester group. It cannot reduce ester group. It will attack here. It will attack here. So what here is C double bond O CH2 C like this. Am I right? I did not write the complete structure, but this is the group. Ketone group is there. So when ketone group is there, reduction means addition of hydrogen. You just add 2 hydrogen. Sorry, H2 means 1 hydrogen will be attached to this one and other will be attached to this one. So all the things remain the same. So what we get here is that in this place you are getting ONH and one H is attaching with here, it enters here, other thing remain same. Very simple if you know the technique, otherwise you can't. This is second from your textual question. Other one is CH3, CH, CH, CHO, CH3 and this. Am I right? And this is sodium borohydride. Am I right? Again, you see its action is on this one. So if you see this group, then you write this group as like this. Am I right? You write this as it and add up 2 hydrogen. One is here, other is here. So are you not getting that group as COH and 1 hydrogen here, other hydrogen already is there. So CH2OH means you are getting CH2OH and other thing will remain same. CH3, CH2, CH, CH will remain same. That your conversion or action is just on these two. If you do not know the trick, if you do not know the rule, you can't proceed. Next one is a question is given. it is a very tricky question. If you do not know the concept, you can't. I think it is CH2OH. Am I right? So, a lots of things you have to understand, otherwise you can't proceed. I will give you the simple hints. The problem is with the choice of Grignard reagent. How will you choose Grignard reagent? With what type of Grignard reagent? And what will you attack? What will be your reactant? Okay, you have to choose two things. So, one is nothing but aldehyde. Because a bit earlier I have shown you, we have prepared 1 degree alcohol, 2 degree alcohol and 3 degree alcohol. From 1 degree we derive from SCH, 2 degree from this and 3 degree from ketone. You keep it in mind. Am I right? So, here your alcohol is 1 degree alcohol. Am I right? Your alcohol is 1 degree alcohol. Means your starting material must be this. Okay? Choice is main. If you can choose, then you can. Otherwise you can't proceed. So you write H, C, H, formaldehyde. Now the matter is resting upon Grignard reagent. Since this carbon is attached to 2-methyl group, our Grignard reagent should contain 2-methyl group, that is secondary part, and with this magnesium bromide. Secondary part will be there. So the simple trick was, this is plus and this is minus, and this minus will attack over here and this will change like this. Am I right? So what we get is H, C, H, O, Mg, Br, and here you are getting CH, CH3, halting 2. Now on acid hydrolysis, are you not breaking this as technique I have mentioned? So what you are getting is, I am arranging it, CH3 halting 2, CH, CH2, OH. So is it not this? You think, is it not this? Yes. So we are successful in preparing CH3, CH2, OH from Grignard reagent. Am I right? Number 2 is this from Grignard reagent. Again your question arises, what will we take? What will be the structure of Grignard? And what is the structure of other compound? So since it is 1 degree, again it must be HCHO. H, C, H, double bond O. Then Grignard, since that group is attached, we will choose a Grignard with this group. Simple, very simple. And whatever trick is here, this is plus and this is minus. This will attack here and this will be withdrawn. This will be H, C, H, O, N, G, B, R. Am I right? Our next step is hydrolysis, and that hydrolysis again is plus and O is minus. If you practice over and over again, you can't. You understand first, then proceed. Automatically you can. Otherwise, without any trick, you will not be successful in getting the desired result. Always you will make mistake. So what you are getting is CH2 above, CH2, and OH is here, OH, and here you are getting this. This is the beauty of chemistry. If you know whatever is the complicated question is, you can answer this. Am I right? So this is the way we can solve each and every type of reaction. How you have enjoyed the class well. If you find the class well, you subscribe and let others to know by sharing. This is the end of today's class. In the next class, I will start with reactivity. Reactivity of alcohol and phenol. Thank you lots for being with me patiently from first to last.